And, well, one third application that we didn't have time to discuss yesterday, that I will mention very quickly, is to find components of, so let's say find the component of a vector A along a direction U, so some unit vector. So let me explain. Let's say that I have some direction, for example, the horizontal axis on this blackboard, but it could be any direction in space. And to describe this direction, maybe I have a unit vector along this axis. Let's say that I have any other vector A, and I want to find out what is the component of A along U. So that means what is the length of this projection of A to the given direction. Okay, so this thing here is the component of A along U. Well, how do we find that? Well, we know that here we have a right angle, so this component is just length A times cosine of the angle between A and U. But now that means actually we can compute it very easily because, well, I could, that's the same as length A times length U times cosine theta, because U is a unit vector. It's a unit vector. That means this is equal to 1. And so that's the same as the dot product between A and U. Okay? So that's very easy. I mean, of course, the most obvious cases of that is, say, for example, we want just to find the component along I hat, the first axis, the unit vector along the x-axis. Then you do the dot product with I hat, which is 1, 0, 0. What you get is the first component, and that's indeed the x component of the vector. Similarly, say you want the z component, you do the dot product with k. That gives you the last component of your vector. But the same works with a unit vector in any direction.